Well, hello pre-calculus students. Today's notes are on conic sections, specifically circles, parabolas, and ellipses. So what we're going to do is we're going to define each of these and then go through a problem dealing with each of these. So 3 examples today, 3 definitions, and let's start with circles. So we've worked with circles numerous times in our mathematical careers. By definition, a circle is a set of all points in a plane equidistant from a given point. Which makes sense. You think about a point in the middle, and all the points that are the same distance from that point make up a circle. So here's your standard form of the equation of a circle. The equation of a circle looks like this. In parentheses, x minus h squared plus y minus k squared equals r squared. And you might have seen this formula from your geometry days before, so let's just talk about what some of those parameters in the equation stand for. So h and k is the center of the circle. R is the radius of the circle. So if we have our equation in this standard form, we can graph our circle because we can graph our radius, wherever that point is, and then we can count left, right, up, down, whatever our radius is, and make our circle. Now, our work in this unit is going to be getting our equations into this standard form, because once it's in this form, doing the rest of the work isn't bad. Okay, so let's take care of an example together. First example, take a sec to jot this down. It says sketch the conic section given by this equation. And the first thing you might notice is that this doesn't look like the equation on the previous page. Well, this is a circle, and we can tell it's a circle because we have an x squared plus a y squared. We have 1x squared, if that coefficient of x squared and y squared is the same and they're added, this will be a circle. But to write it in standard form, here's what we need to do. I'm going to first group my x's together, x squared minus 6x, and then I'm going to leave a space. Then I'm going to group my y's together, plus y squared plus 2y, and then I'm going to leave a space. And see that minus 6? Let's add 6 to move it to the other side. So I'm going to say equals 6. Same equation, just written in a little bit different order. Now, if you recall from earlier this year and from your Algebra 2 days, we need to complete the square to put a number here. We want these 3 terms to be what's called a perfect square trinomial. And if you take half of negative 6, that's negative 3, and square that, you get 9. So if I put plus 9 right here, these 3 terms can be factored. It's called a perfect square trinomial. To keep things balanced, I have to put plus 9 on the other side. Now let's do the same thing here. We want these 3 terms to be a perfect square trinomial. So I'm going to take half of 2, which is 1, square that, I get plus 1. And I'll put plus 1 over here to keep things balanced. So now, these first 3 terms can be factored as x minus 3 times x minus 3, which we can write as x minus 3 squared. These next 3 terms can be factored as y plus 1 times y plus 1, which we can write as y plus 1 squared. Equals, let's put this stuff together over here, so it equals 16. So now this is the exact same equation that we started with. It's just written in a different form. It's written in standard form. It makes it so we can tell right away what the center is, right away what the radius is. Okay, so let's answer our questions here. So the center of this circle is going to be 3 and negative 1. And here's how I like to think of that. Whatever number you can plug into this set of parentheses, and whatever number you can plug into this set of parentheses to make it equal 0, that's your center. The radius is 4. Remember, this was r squared, so the square root of this will give us our radius. Now to graph that, we can go to our center point. From that center point, I'm going to count 4 units up, 4 units to the right, 4 units down, and 4 units left. And I'll try to make this a nice smooth curve. Oh my gosh, this is not very pretty. But that's not too bad, I guess. So there's our circle given by this equation. Okay, so that's the first conic section we're going to tackle today. Here's the second. So first of all, parabola. You've seen parabolas before. You saw them in Algebra 1, Algebra 2, earlier this year in pre-calc. Here's the definition of a parabola. You've probably never defined it. It's a set of all points in a plane equidistant from a point and a line. So we have a point and a line. All the points in a plane the same distance from those two make up a parabola. So for example, this point's halfway between those two. This point is also equidistant from them, as is this. There's a point up here that is the same distance from the point that it is from the line. Same thing here. If we find these points and connect them all, they make a parabola. And although you've dealt with parabolas numerous times, you probably never defined it in this way before. Okay, standard form of the equation of a parabola, and I'll call this vertex form. So a parabola has the form y equals a times in parentheses x minus h squared plus k. Now we've seen this before where we know h and k are the vertex of the parabola. So it looks a lot like in that previous formula for the circle, h and k were the center, now h and k are the vertex. Now here's something else that we haven't seen. I'm going to write down a equals 1 over 4p. And p is going to be the distance from the vertex to the focus. And you might say, what is that? We've never seen that before. But if you look at that drawing that I made, the vertex is this point. The focus is this point here. That distance there we can find by setting a, that number in front, equal to 1 over 4p. Now, ladies and gentlemen, this is the equation when you're talking about a parabola that opens up or down. If you have an equation like this, x equals a times y minus k squared plus h, that is going to give you the equation of a parabola that opens left or right. H and k is still the vertex. A equals 1 over 4p will still give the distance between the vertex and the focus. But it is possible, now this is what you've seen a lot in the past in this class and in previous classes, but it's possible to think of it this way and have that parabola open left or right. Okay, so just like with the circle, let's talk about how, if we're given an equation, how to get it in this standard or vertex form, and then how to graph everything we know. Oh, one last thing. We talked about the vertex, the focus. This line down here is called the directrix, and we're going to find the equation of that line also. Okay. So here's our second example. Sketch the conic section given by the equation. Now, we can tell it's a parabola because notice there's an x squared, but there's not a y squared. Remember with the circle, there was an x squared and a y squared? With a parabola, only one of those variables is squared. Okay, so here's what we're going to do. I'm going to group my x's together, x squared minus 4x. I'm going to leave a space. I'm going to be doing a lot of completing the square in this unit. But then I'm going to take that 4y and the 8 and move them to the other side. Equals negative 4y minus 8. Okay, to complete the square, same as before, we take half of this number, that's negative 2, and square that. That gives us plus 4, which gives us over here plus 4. And the whole reason we do that is because these three terms make up what's called a perfect square trinomial. We can factor that as x minus 2 times x minus 2, which I'll write as x minus 2 squared. Let's bring these terms down, and while we're at it, we'll combine those like terms. That gives us negative 4y minus 4. Okay, now to write this in that vertex form, I'm going to need to factor out a negative 4 from both those terms on the right. So let's keep this exactly as is. let's write this as -4 times y plus 1. We factor that number, that coefficient out, so we have just one y. At this point, we want to divide both sides by -4. Another way to think of divided by -4 is to multiply by -1/4 on both sides. That will give us -1/4 times x minus 2 squared equals y plus 1. And then my last step, let's subtract 1 from both sides. So that gives us -1/4 times x minus 2 squared minus 1 equals y. And there's our vertex form of this parabola. Now, some things we know. Let's answer some questions. Let's make our graph. Our vertex of this parabola is the point 2, -1. Careful. With those parentheses, you think, what can you plug in there to make that equal 0? Since this isn't in parentheses, we'll write it as -1, just as is. I'm going to get that point right away. 2, -1. There's our vertex. Now, based on the equation y equals x squared, this parabola is going to open like a U upward or like a U that faces downward. Since a is negative, this parabola is going to be a U facing downward. Let's be more specific. I want to know the focus of that parabola. Well, here's how I find it. -1/4, that's our value for a. That equals 1/4p. Okay. To solve for p, we can cross multiply here. That gives us -4p equals 4. Divided by -4 gives us p equals -1. That means my focus is 1 unit below the vertex. So here's my focus. It also means the directrix is a line 1 unit above the vertex. So here's my directrix, this horizontal line. And my parabola is going to look something like this. We could get more specific points if we wish, but I think we've got everything we need. So that focus, I'll write that down. It's 2, -2. And the directrix, it's the equation of a line, so it's not a point, so the line is y equals 0. It's a horizontal line that goes through the y-axis at 0. Okay. So, given the equation of a parabola, that's how we can write it in this vertex form. Once it's in vertex form, we know how to find the vertex. Getting the focus is new. We have to use this new equation. -1/4 equals 1/4p. P tells us the distance the vertex is from the focus. Also the distance the directrix is from the vertex. Okay, so that's our second conic section. Let's go to our third. Third conic section, an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from 2 points is equal. What does that mean? Well, it means if I give you 2 points, and I say find all the points that have the same sum, like if we add the distances from here, you get the same thing. Like, for example, this point here, and this point down here. If you add the distance to those 2 points, you get the same thing. But also over here, if you find the distance from that blue point to those black points and add those distances, that's the same as what we had to start over here. And actually, this shape is going to be like an oval shape that goes around these 2 points in the middle. And that oval's really bad quality. I apologize for that. I hope you get my idea. But here's the deal. An ellipse has a number of attributes that we need to talk about. These 2 points that define it are called the foci. Each one is a focus. So there's 2 foci to an ellipse. There's a center right in the middle. There are vertices to your ellipse right here and here. Some textbooks will tell you there are 4 vertices here and here also. So because you may see a case where you need 4 vertices, I'm going to talk about all 4. Some textbooks only talk about the 2 that are in line with the foci. Okay, so when we talk about an ellipse, here's our standard form of that equation. In parentheses, x minus h squared over a squared, that's kind of different, plus y minus k squared over b squared is equal to 1. Okay, what do all these variables mean in this equation? Well, just like with a circle, h and k is the center. And you know, an ellipse is really just a stretched out circle, so it makes sense that this is similar to the equation of a circle. Now, this number down here below the x's, a is going to tell us a stretch in the x direction. Okay, so whatever's below the x's, the square root of that is the stretch in that direction. Likewise, the b is going to be the stretch in the y direction. Now, sometimes the stretch in the x direction is more than in y, which makes your ellipse go left and right. Sometimes the stretch in the y direction is more than x, which makes your ellipse go up and down. To find the foci, here's the formula we use. C squared equals a squared minus b squared. And careful, sometimes it's b squared minus a squared. Essentially, it's just the bigger of the two minus the smaller of the two. Okay? But once you find c, c is the distance to each focus. This will make sense when we see an example. Okay, so let's jump into our final example with today's notes. Sketch this conic section. Now, again, it looks pretty complicated, but we're going to write it in standard form. And we can tell it's an ellipse because you have an x squared plus a y squared. But notice you have coefficients in front of x squared and y squared that are not equal. Meaning your stretch in the x and y direction will not be the same. Okay, so let's write this in standard form. Just like with the circle, we're going to group the x's together and group the y's together. I'm going to move that 256 over to the right-hand side. Now careful, notice I didn't put the underlines because I don't want you to try to complete the square. Completing the square only works if you have one x squared or one y squared. So what we have to do next is factor out, in this case factor out 25 from both of these terms, and factor 9 out of both of these terms. And now we're ready to complete the square. Same pattern we saw before. We take half of this number and square it. Half of this is -4. Square that, we get plus 16. Now careful. To balance that out, do not write plus 16 on this side, because what we're really adding is 25 times 16. Well, 25 times 16 is 400. So that's what's going to balance on the right. Let's do that again. With the y's, half of this number is 3. Square that, we get plus 9. Do not put plus 9 on the right, because what we're really adding is 9 times 9. Let's put plus 81 over here. Okay, so now I can write this, it's going to be close to that standard form. So I've got 25 times this perfect square trinomial, factors as x minus 4 times x minus 4. Plus 9 times this perfect square trinomial, factors as y plus 3 times y plus 3. Now these numbers over here, I'm going to have to grab my calculator for that. I need to add those values together. So negative 256 plus 400 plus 81 is equal to 225. So I've got here a plus 225. Okay, one last step to get it in standard form. Oh, I'm sorry, it's not plus, it's equals 225. My apologies. Make sure that's an equals in there. basically follows right there. So that's an equal sign. All right, last step. Let's divide every term by 225. If we do that, that will get this into standard form. And essentially what we're doing, well, on the right, 225 over 225 equals 1. Good, that's what we want. For each of these, we want to simplify or reduce these fractions. Well, if you divide top and bottom by 9, you get 1 on top, so we're just going to write 1y plus 3 squared, and we get 25 on the bottom. This fraction, if we divide top and bottom by 25, we get 1 on top, so we're just going to say 1 times x minus 4 squared, and we get 9 on bottom. Okay, now we know everything we need to know. Let's make our graph. Let's come up with all of our terms, our defining characteristics of this ellipse. The center is the values we can plug into these parentheses to make it equal 0 and 0. So that's going to be 4 and negative 3. So I'm going to count 1, 2, 3, 4 right, 3 down. There's the center of this ellipse. Now this ellipse stretches 3 units in the x direction and 5 units in the y direction. So if I count 3 left and right and 5 up and down, I have the vertices of this ellipse. And I'm just going to connect these dots. And I apologize for this not being the smoothest curve. That's not too bad. But let me list these vertices. And again, some textbooks will tell you an ellipse has 2 vertices. If that's the case, it would be the up-down ones, because those go along what's called the major axis, the bigger axis. Some textbooks tell you it has 4. I'm going to list all 4. So I'm going to say 4, comma 2, and I'm pulling these right off my graph. 4, comma, what is that, 3, 5, that's going to be 8. Let's see here, 1, comma, negative 3, and 1, 2, 3, 4, 5, 6, 7, comma, negative 3. To find my foci, we use this equation, c squared equals a squared minus b squared, which is essentially bigger minus smaller. So I'm going to say c squared equals 25 minus 9, which is 16. Take the square root, you get c equals 4. Meaning my foci are 4 units away from the center. Now, how did I know to count up and down? Well, that's our major axis. It's stretched more up and down, so the foci will be counted up and down. And I'm going to pull those right off of my graph. So my foci are the points, let's see here, 1, 2, 3, 4, comma 1, and 4, comma 1, 2, 3, 4, 5, 6, negative 7. And there are all the characteristics I need of an ellipse. All right, ladies and gentlemen, hopefully working with these conic sections makes sense to you. Please reach out if you have any questions, and good luck getting your conic sections in standard form, graphing, and coming up with all the characteristics of those conic sections.